Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem number 18. Okay. Fluid mechanics. Problem number 18. As usual, we first come towards its statement. For a seller of a new house, for the seller or keller, whatever may be the exact pronunciation carries second importance in our problems. Okay, for the keller of a new house, a hole is dug in the ground with vertical sides going down 2.40 meter. A concrete foundation wall is built all the way across the 9.60 meter width of the excavation. This foundation wall is 0.183 meter away from the front of the cellar hole. Okay, dear students, so far three quantities have been mentioned. Okay, 2.40 meter, 9.60 meter and 0.183 meter. Okay, so for the purpose of calculation of volume, we will multiply all these three quantities. Okay, as we know that volume is equal to length into width into height, and volume is a three-dimensional quantity and is expressed in meter cube or centimeter cube, etc. Okay. Next part of the problem is, during a rainstorm, drainage from the street fills up the space in front of the concrete wall, but not the cellar behind the wall. Okay. The water does not soak into the clay soil. Find the force the water causes on the foundation wall. Okay. What we have to find out? We have to find out the force which the water causes on the foundation wall. Okay. Dear students, next, a comparing situation is given. For comparison, the weight of the water is given by 2.40 meter into 9.60 meter into 0.183 meter into 1000 kilogram per meter cube into 9.80 meter per second square, alternatively becoming equal to 41.3 kilonewton. That is 41.3 into 10 raised to the power 3 Newton, or 41,300 Newton. Okay. Dear students, here first three quantities determine the volume. Second quantity determines the density of water. Okay. Third quantity is the value of acceleration due to gravity. Okay. Now we come towards solution, and first we see whether this comparing situation is correct or not, and how it has come to this value. Okay. Solution. First we consider the given comparison situation. Okay. Volume equal to V equal to 2.40 meter into 9.6 meter into 0.183 meter. Okay. Dear students, as I have described earlier that volume is a three-dimensional quantity and is equal to length into width into height. So it has become equal to 4.21632 meter cube. Okay. From the first three quantities given in the data provided, we have successfully calculated the volume. Okay. Now we come towards the definition of density, rho, which is equal to mass over volume, mass per unit volume. Okay. This implies that mass alternatively becomes equal to density into volume. Okay. Now we put the values of density and volume. Okay. We know that density of water is 1000 kilogram per meter cube and volume we have already calculated in the above step. Okay. So M becomes equal to 1000 kilogram per meter cube into 4.21632 meter cube. Meter cube will be cancelled out with meter cube and mass will become equal to 4216.32 kg. Okay, dear students, in the next stage of our problem we will show a table of densities in which it will be shown that density of water is equal to 1.0 into 10 raised to the power 3 kilogram per meter cube. Okay, so mass has become equal to so many kilogram and weight which is equal to mg. M is this and g is this. This is a physical constant. Okay, we know from very earlier classes that value of acceleration due to gravity is 9.8 meter per second square. Okay, so this becomes alternatively equal to 41319.936 Newton. Okay, weight has become equal to this, and this is absolutely correct. We do not need to convert it into any other form. However, as a matter of discretion, we have converted it in kilonewton. Okay, by dividing it by 1000. When we will divide it by 1000, it will become 41.319936 kilonewton. Okay, kilo stands for 10 raised to the power 3. Okay, so these two values are exactly equal. We have just changed the shape of this quantity. Okay, now we come towards the actual problem. Okay, that was only comparison situation. We had found whether comparing situation is correct or not. Okay, we know that the pressure at a depth h in a liquid of constant density rho is given by pressure P is equal to density rho into acceleration due to gravity g into height h. Okay, height or depth almost equivalent terms. Okay, equation number 1, where g is the acceleration due to gravity. Okay, dear students, in the bracket a deriving situation is explained. Okay, these three dots indicate because we know that pressure is equal to force per unit area, and according to Newton's second law of motion, F is equal to mg. Okay, and we know that density is equal to mass over volume. So if we keep mass on one side, then mass will become equal to density into volume. So density into volume into g over a. Okay, in the next step, rho and a are unchanged, while similarly g is also unchanged. However, in place of volume we have expressed it in terms of area into height. Okay, area is a two-dimensional quantity and height is one-dimensional, and these two after multiplication become three-dimensional and represent volume. Okay, from here A will be cancelled out with A, that is area, and hence pressure will become equal to rho GH. Okay, using rho equal to 1000 kilogram per meter cube, which is a constant given in the table of densities. Okay, in the next step of this problem we will also show that table. Okay, similarly G equal to 9.8 meter per second square is also a constant acceleration due to gravity. Okay, moreover H is 2.40 meter divided by 2 equal to 1.20 meter. This is the most important point which requires our concentration, our thinking, why we have done so. Okay, dear students, you can see here that with vertical sides going down 2.4 meter, it is given 2.4 meter, but we have divided this quantity by 2 and have used the value 1.20 meter. Okay, with vertical sides going down 2.40 meter. Dear students, actually we are concerned with the central position of this quantity. Okay, because half of this is above the earth and the half is below. Okay, that is why. Otherwise this is not like diameter and radius. We know that radius is equal to half of the diameter. Okay, but here we have divided by 2, not in the sense that it is a diameter and radius, but this is a special case. Okay, in which we are focused at the central position of this measurement. Okay, that is why we have taken 1.20 meter. Okay, in equation number 1. Pressure has become equal to 1000 kilogram per meter cube into 9.8 meter per second square into 1.20 meter is alternatively becomes equal to 11,760 kilogram per meter second square. And we know that kilogram per meter second square is equivalent to Pascal. So in place of this we can write PA, Pascal. Okay, so we have just used conversion factor. Okay, in the next step we have divided this quantity by 1000, so it has become 11.760 kilopascal. Okay, because kilo stands for 10 raised to the power 3. Similarly, in the next step we have again divided it with 10 and it has become 1.176 into 10 raised to the power 4 Pascal. Okay, because here it was 10 raised to the power 3 and by dividing by 10 it has increased by further 1 power of 10. Okay, 10 raised to the power 4. In the next step we have again divided it by 10 with the result that this power 4 has increased to 1 step more. Okay, so it has alternatively become equal to 0.1176 into 10 raised to the power 5 Pascal. Okay, so dear students, no difference. Up to this value our answer is complete, solution is complete, but we have just described this quantity in different shapes. So it is just a matter of discussion. We are not bound to adopt these steps. Okay, Now we come towards the next part. Okay, we know that the pressure P in a fluid is the force per unit area exerted by the fluid on a surface. That is, pressure is defined as force over area, force per unit area, equation number 2. Okay, using pressure equal to 11,760 Pascal, which we have already calculated in the above this. Okay. Okay, using pressure equal to this, area in the first part we had found volume, that is, we had multiplied three quantities, but here we have only found area, that is to say we have multiplied two quantities out of those three quantities. Okay, here, dear students, volume equal to these three quantities, because volume is a three-dimensional quantity, length, width, height, but area is a two-dimensional. That is why area has become equal to these two quantities multiplied by each other, and hence area has become equal to 23.04 meter square. Moreover, we know from table of conversion factors that 1 Pascal Pa is equal to 1 Newton over meter square, equal to alternatively becomes equal to kilogram per meter second square, and alternatively becomes equal to joule per meter cube. In equation number 2 we get. Dear students, here we are not concerned with this last equivalent value. Okay, so in place of pressure we have used this value. In place of F we have not put any value, because we have to find out force F. And similarly, in place of area A we have used 23.04 meter square. This implies that F becomes equal to, this will be multiplied with this quantity. Okay, and hence F will become equal to 11,760 into 23.04 kilogram meter per second square. Yes, friends, because here m square will become in the numerator on left hand side, and 1m will be cancelled out with 1m. So 1m into kilogram over second square, this will be left, and this is equal to Newton. So F has become equal to, by simplifying these two quantities, okay, force Newton has become equal to 270,950.4 Newton. Okay, our answer is quite complete to this extent, that force F has become equal to 270,950.4 Newton. Okay. However, in the next step we have converted this value in some different shape by dividing it by 10,000. Okay, so it has become equal to 2.70950 into 10 raised to the power 5 Newton. Okay, because dear students, if we divide it by 10, it will become 5.04 into 10 raised to the power 1 Newton. If we convert it in 0.50, then it will be 10 to power 2. When this 270 point, then 10 raised to the power 3. When 27.09, then 10 raised to the power 4. And when it is written as 2.709, then it is 10 raised to the power 5 Newton. Okay, so here our answer is complete, our solution is complete, what we had to find out force. Okay, here this is the table of densities, where density of water is given in the left column at serial number 1 2 3 4 5 5 serial number 5, water 1.00 into 10 raised to the power 3 kilogram per meter cube. It can be written as 1000 kilogram per meter cube. Okay, now we come towards the reference from where we have chosen this problem. Our reference book is Physics for Scientists and Engineers with Modern Physics. Authors are Raymond A. Survey, John W. Jude Jr. Publisher is Cengage, and its 9th edition 2014 has been adopted. Here chapter number 14 under title Fluid Mechanics is our concerned chapter, and this problem is enumerated at serial number 13 of the exercise given at the end of this chapter, that is exercise number 14.13, and this is the end of our module, our problem. Okay.